So we move on from sequences to series, and remember, we talked a little bit about this before, but a series is just the sum of a sequence. The example we're going to start with is an arithmetic pattern of adding 1 plus 2 plus 3 plus 4 all the way to 1,000. If we were to do this by hand or do it on a calculator by hand, plug all those numbers in, it would take quite a while. We know we can use the summation notation on the calculator, but I'm going to ask that you use the formula we're going to derive real quick. Now, initially this formula was derived by a famous mathematician named Gauss, and what's kind of astounding about this is that when he did this, Gauss was 10 years old. And math prodigy, much like Mozart was a musical prodigy. But this is kind of how he went about doing it. He took and wrote the sequence backwards. So he took 1,000, added 999 plus 998, etc., all the way down to 2 and 1. And then took and added the two columns up, and notice that, hey, we've got a repeated sum of the same number over and over again. And with that, he said, well, how many of those repeated sums do I have? I have a sum of 100 or 1,001, a total of 1,000 times. So that's just multiplication. But if I'm adding two of these sums together, I'm double heavy. So if I divide by 2, I'll get my sum. And he did this over and over again for a bunch of arithmetic sequences and found that this pattern exists every single time that the sequence was arithmetic. And he said, well, this term right here corresponds to the number of terms in my list. This term here corresponds to my first term plus my last term. And I'm always dividing by 2, and that's going to equal my sum. And from that came up with the following equation, where the sum of n terms is equal to the number of terms multiplied by the sum of the first term plus the last term over 2. So we'll go ahead and use that to solve a couple of examples. So in this case, we have the sum of n terms, and we don't know what n is quite yet, but that's equal to n times the first term plus the last term over 2. So let's fill all this in. Sum of n terms is equal to n, first term 3, last term 15, 63, and I'm going to divide that by 2. So what I need to do is find n. And we do that by using our sequence equation, which says the nth term is equal to the first term plus the difference times n minus 1. The last term, or the nth term in this case, is 1563. First term is 3. Difference is 10 in this case. And that's multiplied by n minus 1. Subtract 3 from both sides, get 1560 is equal to 10 times the quantity of n minus 1. I divide both sides by 10, so I get 156 is equal to n minus 1, and 157 is equal to the number of terms. So I plug that in over here, and I get 157 multiplied by 1566 over 2 is going to be equivalent to my sum, and now we know that's of 157 terms. And that sum is going to equal 122,931. Let's move on to a sigma notation type problem. Again, we're going to need the number of terms, and you'll notice we start at n equals 1 and go to n equals 100, which means there's got to be 100 terms. So that's the sum of 100 terms is equal to 100 times my first term plus my last term. And again, we're assuming that this is all arithmetic, so I'm going to plug in and check just to make sure this is arithmetic. So when I plug in a 1, I end up with 7. When I plug in a 2, I end up with 9. Plug in a 3, I end up with 11, etc., etc., etc. all the way till n equals 100, and I get 205. So this is appearing to be arithmetic, so I'm going to continue to plug into this equation. My first term was 7. The last term was 205. I'm going to divide by 2. So what I've got is basically 50 multiplied by 212. And that's going to give me a total of 10,600. In this next example, it's also a sigma notation. So again, we notice though this time that n is equal to 3. So the first term I'm going to plug in is 3. And that'll get me 7 minus 9, which is negative 2. Plug in 4. When I plug in 4, that's 7 minus 12, or negative 5. Plug in 5. 7 minus 15, which is negative 8. So this is appearing to be arithmetic. We're going to plug in that last term, n equals 64. And I end up with negative 185. And now I start plugging into my equation. So I need to determine how many terms there are. And if you'll notice, when I go 3, 4, 5, 6, if I had n equals 3 to n equals 4, I can't say I just have one term because I have two terms. So it wouldn't be enough to just take the top number, subtract the bottom number, and say, well, that's how many terms I have. The number of terms is actually the top minus the bottom of the sigma, and with 1 added to it. Because like I said, if we had n equals 3 and n equals 4, there's two terms, 4 minus 3 plus 1. So in this case, number of terms is going to equal 64 minus 3 plus 1. So in this case, we've got a total of 62 terms. So if I want to find the sum of the 62 terms, I take 62 multiplied by my first term, which was negative 2, plus my last term, which was negative 185, all over 2, which is 31 multiplied by negative 187, or 5,797. Next, we're going to move into a geometric series. Gauss again did the work on this, found that he couldn't just rewrite the series backwards and find any kind of comparison that happened. So what he did was he said, well, what if I take and multiply my series by the ratio? Well, what that did is he found that the ratio times the first term was equal to the second term. Then the ratio times the second term was equal to the third term. And it just keeps going in that pattern. And he found out that when he took the ratio and multiplied by the last term, remember, if I multiply something with a common base, then I take and add the powers. So this last term ended up being the first term times r to the n power. Then what he did is he said, okay, I'm going to take, and I notice now that every vertical column matched up except for the first and the last. So he said, well, if I subtract all that from both sides, then I end up with the sum of n terms minus r times the sum of n terms is equal to the first term minus, because everything went away in the middle, the first term times the ratio raised to the number of terms. And he said, but what I really want to find is this sum value. So he factors gets 1 minus r. You could actually factor this as well. You get a1 over 1 times 1 minus r raised to the n power. And then the sum is equal to the first term times 1 minus the ratio to the nth power all over 1 minus the ratio. Again, it was all done by a 10-year-old. And this is what we came up with. So once again, that's the sum of n terms. The first term, the ratio, the number of terms. And let's use this to find a few more sums, this time of geometric series. So we're going to find the sum of the first 12 terms in a geometric sequence. We know that we're looking for, once again, s sub 12 is equal to the first term times 1 minus the ratio to the nth power over 1 minus the ratios. And you see, in this case, we've got a lot of this stuff already. We have the first term of 4. We have 1 minus the ratio, which is negative 3. The number of terms is 12, so that's raised to the 12th power, over 1 minus the ratio. And this turns out to be just a plug and chug problem. And we end up with a final value of negative 5,000 or 531,440 after putting it into our calculator. Next, we're going to find the sum of a series where I have the first term and the nth term and the ratio. So in this case, if we're going to have the sum is equal to the first term times 1 minus the ratio to the nth power over 1 minus the ratio, we notice we've got that first term, 48. We have 1 minus, and we have our ratio, in this case, of a half. But I don't have n. I have the nth term, and that's 1 over, or 1 minus the ratio once again. So I'm going to need to find n, and we do that with our sequence formula, which was the nth term is equal to the first term times the ratio to the n minus 1 power. And you'll notice we have 48, we have a half, raised to the n minus 1 power is equal to that nth term, which in this case is 48, or I lied, it's actually 3. So what I have is I have 3 over 48 is equal to a half raised to the n minus 1 power. 3 over 48 goes to 1/16, which is a half to some power, n minus 1. 1 over 16 is a half to the 4th, which is equal to a half to the n minus 1 power. So 4, since I have the same base, is equal to n minus 1, and n is equal to 5. So now that I have n equal to 5, I can plug that back into my equation for the missing n. So what I have is I have 48 times 1 minus 1 half raised to the 5th power over 1 minus a half, which is a half. Again, we're at plug and chug stage, and we end up with a total of 93. Let's do one more. We have the second term and the 5th term, and we want to find the sum of the first 7 terms. Well, I'm going to need to find the first term based on that, and I can find the first term by allowing this guy right here to act like my first term. We've done this before. Let a sub 2 equal a sub 1. Then that will mean a sub 5 is equal to a sub 4. And what I'll have next is I'll have 972 would equal negative 36 times the ratio, which I don't have, to the 4 minus 1 power. Divide both sides by 36, and I end up with negative 27 is equal to the ratio to the 3rd power. Cube root both sides, and I have a ratio of -3. And with this, I should be able to get everything done in the problem. So again, I want to find the sum of the first 7 terms. It's geometric, so I need my first term. And if I know my ratio is -3 and a sub 2 is equal to -36, then I just need to divide by that to get my first term. So a sub 1 in this case would be a positive 12. So I have 12 times 1 minus my ratio, which we just said was -3, raised to the 7th power over 1 minus my ratio. So again, I've got 12 times 1 minus -3 to the 7th over 4. 12 and 4 will reduce to a 3. And then we've got, once again, a plug and chug. And I end up with the sum of the first 7 terms equaling 6,564. So in this problem, there's a little different spin. We have actually the sum. So if I have s sub 6, that's equivalent to my first term times 1 minus my ratio, which is a half, raised to the 6th over 1 minus my ratio. And I have to find the fourth term. Well, they give me the sum, which is 315. First term's unknown. 1 minus a half to the 6th. That's 1 over 64 over a half. And I can find my first term from here, and then with that I'll use that to find my fourth term. So in this case, I'll take and plug all this into a calculator and see what I come up with. And I end up with 63 over 32 times the first term is equal to 315. Multiply by 32 over 63 and get my first term. And I end up with 160. So now that I have my first term, I can use my sequence equation, which is the nth term is equal to the first term times the ratio to the n minus 1 power, to find that fourth term. So I'm looking for the fourth term. It's going to be equal to 160 times my ratio, which we know is a half, raised to the 4 minus 1 power. So in this case, I have 160 times 1/2 raised to the 3rd, or 160 divided by 8 in this case, which is 20. And that's my fourth term. That's all we've got. Do your My Math Lab, fill out your summary, and we'll chat more tomorrow.